Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 111's on the screen, and that shouldn't take you long. Get a Cornell note right after that because we have a lot of stuff to cover today. We're moving on. Yeah. So, yeah, copy and go. All right. So, number 1. What'd you get for 1A? Frida. 1/32, that is correct. How about B? Jaden. Eight, that is correct. How about C, Mr. Q? Well, pay attention to this one. We're going to need this skill. We've been doing this since last week. What was the 2 inside of the radical before it came out? 4, that is correct. So we end up with square root of 2 times 4. What is square root of 2 times 4? Square root of 8. Make sure you keep that in mind. Let's say we're going to revisit that today. Number 2, 2 to the x minus 4 is the same as 2 to the x over 2 to the 4, which is 16. Next, what is half power? Tell your neighbor, what is half power? Diego, Romo. Square root, yes. Square root of 9 is 3. That is correct. Square root of 64 is 8. And let me go to part C. Make sure you follow along. Ivan, can you get the door, please? Here we go. The last one, I need to rewrite it. So this becomes 27 to the 1/3 times 2. Because 2/3 is the same thing as 1/3 times 2, yes? All right. However, I need to start with this part. If 1/2 was square root, that means that 1/3 is what? Cube root. Cube root of 27. But we still have this exponent. So, what is cube root of 27? That means what number times itself 3 times gives us 27? 3. Bring the exponent over. 3 to the second is 9. Ooh-wee. Go! All right. Let me zoom out. Let's go to number 4. To graph the exponential function, what 3 points do we use? Tell your neighbor again. What are the 3 points that we use for this parent function, exponential? What are the 3 points, Diego Rosas? 0, 1, hold on. So 0, 1, 1, 2, 2, 4. All right, and we're going to move that according to this. Where are we going to move that to? Everyone. 3 to the left and 4 up. Yeah, so 3 to the left, 4 up. So we're going to end up somewhere over here with the 3 points. Yes? All right. All right, our favorite. Sine angle B, cosine angle B, and tangent angle B. Tell your neighbor what you got, please, for those 3. So, perspective angle B. So what is sine JP? Help them out, Juan. 15 over 17. So opposite over hypotenuse. Cosine, Fabian. Eight over 17, that is adjacent over hypotenuse, yes. Last but not least, tangent angle B. Tangent angle B, tell your neighbor. What you get for tangent angle B? Isabella, what you get for tangent angle B? 15 over 8. That is correct. Hands if you got that by yourself. All right. Copy the agenda for today. Okay. Warm-up number 111, logarithmic functions. And home plate pages 755, 756, numbers 5 through 15 only. Kind of windy out there, huh? Just a tiny bit. All right. Your home plate from last time, before we had our Pop Parte Friday, it was an exponential function. And, hold on. Copy the objective. I can define, solve, and evaluate logarithmic functions. But before we do, get your stuff and get out of the way, please. All right, everybody happy where they're at? Good? So, like I said, April is going to be a short month, so make sure you stay focused because this is the last major, I mean, there's another concept, but this is one of the major ones that we're going to be transforming. And hopefully everything we practice on the warm-ups kicks in right now. Here we go. Our objective for today, I can define, solve, and evaluate logarithmic functions. I can define, solve, and evaluate logarithmic functions. So we're doing three things tonight. We're defining, we're solving, and evaluating. Which functions now? Logarithmic functions. In short, logarithmic functions are called logs. So write that in your prayer model, please. So, logarithmic functions, or logs, what are they? Definition. Logs are the inverse of an exponential function. What are logarithmic functions? The inverse of an exponential function. So, before we did the activity with Desmos, we got to the last function, which was exponential. Yes? Yes, Mr. Q. All right, where b has to be greater than 0 and b cannot equal to 1. However, what is b? What does that mean? Who remembers what b is? Tell your neighbor, please. What does b stand for? What does b stand for? If we're talking about exponential functions, b stands for what? B. What does it stand for, Noel? B. Stands for very good. He said base. Hands if he said base. Yes? Yeah, B stands for base. So the base has to be greater than 0 but not equal to 1. However, how do logarithmic functions look like? Here they go. F inverse of x equals log base b of x. Or x equals log base b to get a. Next, I'm going to give you some more now with numbers. These are without numbers. These are with numbers. F inverse of x equals log base 5x, and 3 equals log base 4 to get 64. Copy those. All right. So, what do you guys see that it's so obvious about these examples, everyone? What do you guys notice that it's different from the other functions that we've looked at throughout the year? Talk it over with your neighbor. What's so different about these? Then Caleb's going to enlighten us. What's so different about these to all the other ones that we've seen all year? There's an obvious difference in these. All right, good conversations. Who's going to go? Oh, Caleb. What makes these so different? That's true. This one has a word inside of the function. That is correct. And to be exact, it's the word log. Okay. So with that said, look at the non-examples. Look up. Tell your neighbor why those are not logarithmic functions. Pretty obvious, yes? Ivan, why are those not logarithmic functions? Doesn't have a log. And the first one's not in a function because it doesn't have an equal sign. So our first hashtag has to be function. Keep in mind that the base we're going to be looking at in regards to definition is base B. And we're going to be solving for exponents. Now, logarithmic functions, guys, came about in regards to mathematicians who were trying to figure out we can solve linear functions, quadratic functions, and all the other functions. But when it came down to exponential functions, they were trying to figure out how to rewrite that in a algebraic way so that we can solve for the exponents. And they came up with this in regards to logarithmic functions. So, write your utensils down, look up to the screen, don't copy this. So in other words, a logarithm is an actual question. Here's the question. To what exponent does a base need to be raised to in order to get a given number? So this question can be translated into a function. Look up. Here's the function. This question is this. Let me repeat that again. Don't copy this. Here it goes. It says, to what exponent, what is the exponent, everyone? X. Does base need to be raised? What is the base? B. Need to be raised in order to get a given number. What's my given number? A. This question is here. So in order to practice this, copy this table underneath. One column, title it logarithmic functions. The other column, title it inverse log or exponential function. And we're going to write this function in the first row right there. Copy and go. All right. So here we go. I'm going to start slow. Ready? This is a logarithmic function, but according to the definition, logs are the inverse of what? Exponential functions. So that means I can rewrite this as an exponential function. What do we need to get started with an exponential function? Well, we need a base. What is my base here? B. What is the exponent? What is the exponent? Ivan. X, yes. And all that is equal to the given number. The given number is A. Pretty straightforward, yes? All right. Let's do another one. Now I'm going to use numbers. Here we go. X equals log 2 64. Rewrite that, please. All right, show your neighbor, please. All right. Go, Joel. What do I write, Joel? 2, okay. Equal to. Thank you. Let's do another one. X equals log 5, 125. Right now you're not using your cell phones. I'm going to take them away. My goodness. All right, show your neighbor, see what they got. All right. What you get, Alex? Go. What do I write? Uh-huh. That is correct. Hands if you got that. All right. Let's do some more practice. Copy this, please. Example 1. Write the instructions, please, because this is how the home plate is going to go. Example 1 reads, rewrite the log as an exponential. X equals log 4, 16. Copy that and go. All right, let's see. What'd you get for this one, Alessandra? 4, father of X, equals what? 16. Hands if you got that. All right, let's do another one. Copy this. For this one, you don't need the instructions. Just copy the log. Example 1Q, X equals log 3, 81. Should be just about done rewriting that as an exponential. Share with your neighbor so like that Valente can help us out. All right, Valente, what'd you get? $81. Hands if you got that. All right, let's do another one. Copy this. Example 1 super Q, X equals log 2 to the 1/4. All right. All right, check with the neighbors, see what they got, please. All right, Delilah, what'd you get? To the 1/4. Hands if you got that. All right, from 1 to 5, how come are you changing log to exponential? 5, 5, 5, 5. Okay. Now let's go backwards. We're going to go from exponential to logs. Copy this one, example 2. Rewrite the exponential function as a log. 2 to the x equals 32. 2 to the x equals 32. All right, rewrite that as a logarithm. Check with the neighbors, see what they got. All right, let's see. What'd you get for this one, Alyssa? x equals log 2, 32. Hands, have you got that? Looks about right. Let's do another one. Example 2q, 4 to the x equals 64. Rewrite that as a log, please. Check with the neighbor, see what they got. All right, what'd you get for this one, Anaya? Log 464, hands, have you got that? All right, and one more. Copy this one. Example 2 super q, 2 to the x equals 1/8. 2 to the x equals 1/8. Rewrite that as a log. Should be just about done. All right, check with the neighbor. What'd you get for this one, Dulce? To get 1/8. Hands, have you got that? All right, I think we got it, yes. So for the first part of the home plate, they're going to ask you to write logs into exponential or an exponential into log from 1 to 5. I'll come to borrow you with that piece. Yeah, 5, 5, 5. Okay. Shall we crank it up a little bit? Yes. Okay, let's go to example 3. Now we're going to be solving functions. Copy this one. Solve for x. X equals log 2 to get 1/8. And it's fairly simple. I mean, it's just a process. Solve for x. X equals log 2 to get 1/8. All right. Writing utensils down. Look up to the screen. I'm going to go over the entire process. You'll copy at the end, so you don't have to be copying throughout. Here it goes. 3 easy steps. Step 1. Write as exponential. So that means I need to go 2 to the x equals 1/8. Step 2, and you're just paying attention. My goodness. Step 2, same base. What does that mean, Mr. Q? That both sides of the equation need to have the same base. So 2 to the x equals 1/8. I need it with base 2. 2 to the what gives me 8? 2 to the third. However, it's still not a same base because this is a fraction. What do I need to make it look like that? I need to bring this one to the numerator. So this is 2 to the x equals 2 to the, it can't be a positive 3. Now it has to be a what? Negative 3 because I sent it up there. And step 3, solve. Solve for the variable. In this case, it's x. All I have to do is focus on the exponents. That means x equals negative 3. Copy that, please. All right, so for step 2, for those of you that need to elaborate more, make sure you write a little note for yourself here. Same base what? Both sides of EQ or equation. All right? So, with this first example from 1 to 5, how comfortable are you with these so far? 5 fours, 5 fours, 3s. Okay, let's do another one. Once again, the process, write the log as an exponential, same base for both sides, and then solve. All right, copy this one. Example 3q, x equals log 3 and 1/81. All right. So, I need an exponential function. So, what do I write for this one? Diego Rosas. Go. Thank you. So far, so good. That was step 1. Step 2, they need to have the same base. So I write 3 to the x equals 1 over what? Tell your neighbor what you're going to write on the denominator. All right, Christina, what do I write on the denominator? 3 to the... All right, hands, have you got that so far? All right, next. Do we have the same base yet? Almost. This needs to be going to the numerator, so this becomes 3 to the x equals 3 to the what, Jessica? -4. And at the end we solve, so x equals -4. All right, from 1 to 5, how can I borrow you with these? 5, 5, 5, 5. Okay, let's do another one. Copy this one. Example 3 super cube. X equals log 4, 64. That shouldn't take you long. Copy and go. All right, get us started, please. Lorena, go. All right, Fabian, go. 4 to the x equals. And at the end, x equals 3. Hands, have you got that? Let's go, let's go. From 1 to 5, how come to worry with this? All right, so this is the second part of the home plate. The first part was changing logs into exponential to logs. The second part is solving a logarithmic function. So now let's go to the funner one. Yeah, crank it up a bit. Copy this one, example number 4. Evaluate the logarithmic function, f of x equals log 7 to the x for f of 49, f of 1 over 343, and f of 7 square root of 7. Copy that. I'll walk you through the first one as soon as you're done copying. All right, y'all ready? Here we go. Writing utensils down, look up to the screen. So basically what we have here is a logarithmic function, f of x equals log 7 x, and they want us to evaluate it using 3 numbers, using 49, 1 over 343, and 7 square root of 7. I'm going to evaluate it using the first value. So here we go. So let me zoom in. Okay, writing utensils down, look up to the screen. Here we go. So first things first. Instead of x, what am I going to write? 49. So this is f of 49, and you're just paying attention. You'll copy at the end. Log 7 to get 49. Once we have that, the very first thing in order to solve, we need to go back to the other notation, not function notation. What was, before we got to function notation, it was a variable y. So we leave it as log 7, 49. Why do we need it in this form? Because now we can rewrite this in an exponential. What is the exponential form of this one? Tell your neighbor, please. What would you write as an exponential? Yeah, 7 to the power of y equals 49. And now, same base, 7 to the y equals 7 to the what to give me 49? 7 to the what? 2. Yeah, because 7 times 7 is 49, and at the end, solve. So answer, y equals 2. Copy that, please. All right. So, now that I walked you through the process of one, let's do the other one together. But now instead of 49 here, instead of the x, we're going to substitute what? 1 over 343. So we write f of 1 over 343 equals log 7, 1 over 343. All right, so what's the first thing we do, after we substitute those values in there? Diego Rosas, tell me what you write. Yeah, that is correct. All right, so far so good. Continue from there, Joel. What do I write? Sorry? 7. Uh-huh. $343. Okay. So far so good. Next, we need to have the same base. So 7 to the y equals 1 over what? Tell your neighbor before Jaden gives us the next thing to write. Jaden, denominator, 7 to the what? Help, what? Help him out, Frida. 7 to the 3. Okay. Then we send this to the numerator, so this becomes 7 to the y equals 7 to the negative 3. So y equals negative 3. All right. Next, let's go to the last one. The last one is 7 square root of 7. Okay. I like this one. Here we go. So we write f 7 square root of 7 equals log 7 square root of 7. Okay, I'll give you a head start so you can start setting it up, and then I'll catch up in a little bit. All right, let's see. So, tell your neighbor what you wrote in the next step, so like that Caleb can help us out. Next step after this, what did we write? Next step. Caleb, go. Close. 7 square root of 7. Yes. All right. Continue from there. Who hasn't gone? Oh, Briseida. Go. All right. So far, so good. Yes. All right. But this needs a little work. So here we go. Writing utensils down. Look up to the screen. Now, I gave you plenty of practice on the warm-up. I'm going to do the work to the side so you guys can see this work over here before I write it on the next step. So, question. Look up, please. What was this 7 before it came out of the square root? Tell your neighbor. What was the 7 before it came out of the square root? Everyone? 49, is that correct? Times, what's inside already? 7. All right, can I write 49 in base 7? 7 to the what? Second power times 7 to the first. So can you agree that 7 to the second times 7 to the first is what? 7 to the third power. However, we need it in same base. 7 to the third without the square root. How can I write the square root as an exponent? Tell your neighbor, please. How can you write the square root as an exponent? Isabella. Help her out, Alyssa. times half. That is correct. We just did that on the warm-up. Therefore, how can we write this next here? It's 7 to the 3 halves equals to 7 to the y. Therefore, our answer, everyone, y equals 3 over 2. Now, I'm showing you the work over here. Do you really need to do all this work? No, as long as you know how to transform this into an exponential that has a fraction, you're good. All right. From 1 to 5, I'll come to borrow you with these. You see some 4s, 5s, 4s, 5, 4, 5, okay. And a 10 over here. Okay, good. All right. So do me a favor, copy this next one. See if you can do this next one by yourself. Let me just show you all 3 of them together. Look at that beauty. Like a Picasso, right? No, my bad. Picasso. Let's go. A Picasso. Example. Example 4Q. Write this down. F of x equals log 3x. F of x equals log 3x. And I want you to do the last one. The last one, which is this one. 3 square root 3. You're going to evaluate this one using f of 3 square root 3. I'm going to stop the video right there. Enjoy your home play. Let's go. Oh, before I forget, writing utensils down. Let me record this on the video. Get your phones out. Go to Canvas really quick. Go to our class and go to the last module. There's a new module. Say never what it's titled. What's the new module? Logarithmic. Yes. Click on that, please. Click on that, and then in there you have the home plate, right? But also you have the study guide for the final exam. Yes, parents, I'm giving them the study guide a whole month ahead. So do me a favor, take a screenshot, get your parents to sign that they know that you have the study guide for an entire month. Now I'm going to stop the video. Enjoy. Go.